All right, good morning. Hope everyone's doing well. So I'd like to talk about the ODPs, and then I want to talk about debugging. But I want to talk about ODP 450 in detail and go through 452. But any questions before we get started? Any lingering questions on homework 6, which is due tomorrow morning?
While I was creating code and tried to get separate parts of it to work, I got something called a segmentation error. Can you explain what that is?
Sure, so that's usually just called a seg fault. You've probably heard me use that term. A seg fault is basically, it's a memory access error. And there's a lot of things that can cause seg faults, but a few classic examples that might be related to what people are doing in homework 6 was, for example, if I do something like this, right? The fact that I've declared a car star temp, I have not set aside any storage for temp yet, and I haven't told temp to point somewhere. And then down here, I'm saying let's read 100 characters from standard in, that's the user, and let's store them at the location that temp points to. While temp isn't pointing anywhere in particular, it's probably pointing to 0, which is not an available memory location, so this will throw a seg fault. And if I had done this instead, right, that not only declares temp to be a car star, but it, number 2, sets aside 100 locations in memory, and number 3 sets the value of temp to point to those locations. And so now when I use temp in fgets, it's going to store the input in those locations in memory, and that'll avoid the seg fault. If you process command line arguments and you do something like scanf argv bracket 1, but there is no command line argument given, this will give a seg fault. If you have an array and you copy things into or out of that array, but you go outside the bounds of the array, that will typically cause a seg fault. If you create a string manually and you don't put a null terminator at the end, then something reading from that array of characters will typically keep reading on and on beyond what you meant the end of the string to be, and that'll often lead to a seg fault. It's in some ways, one of the most general errors, but it's always it's always the same underlying cause, which is that there was a memory access that was not legal. But finding it can be tricky. And this is where putting print statements in your code, for example, to know how far you got through your code when the seg fault occurred can help. If you put print statements in for that reason, make sure you always put a new line at the end, because print statements are normally buffered. So, here I am, new line. If you print that out, different spots in your code with different messages, that can help you figure out exactly which line of code is causing the seg fault. When we talk about GDB in a little bit, we'll have another way to step through. The other thing I'll say, though, about seg faults is sometimes they go away. Sometimes adding a print statement to your program will cause a seg fault to disappear. Okay? If that happens, you need to worry. Okay? Don't just say, oh good, it's gone, I guess it took care of itself. It's still there. Okay? So you need to find a different way to figure out where that seg fault was coming from. But it's one of the kind of more annoying bugs to try to pin down in C. Can we use getCar to in homework 6? You can, but you got to be really careful with it. I would recommend using fgets, because getCar will only ingest a single character, and if somebody types in more than one character, every time you call getCar, it'll pick up those buffered characters, and it can lead to some unexpected behavior on your program's part. To wait for the enter input, just call fgets and ignore, the input. Just say fgets temp 100 standard in, and whatever they type when they hit enter, this function will come back, and just don't do anything with the variable. That should be fine. Yeah, so what was just said in chat, exactly. All right, other questions? So I had a few takers for office hours this week. I had a few people in last night, mostly not. My mom actually called me up for tech support, so I had something to do at the end of office hours. But by and large, I'm sitting idle in office hours, and that's really the time to come in and say, my program, works most of the time except in this case, and I can't figure it out. You can screen share, you can run through your code, you can show me what you're seeing, and we can look at your source code, and we can talk about how to pin down the problem from there. It's absolutely way more efficient than emails or listening to lectures or Googling or going to Stack Overflow or anything like that. So, please take advantage of that. My next office hours are Friday, so no more hours till the assignment's due. But, for future reference, take advantage of office hours. All right, other questions? All right, let's talk about 450. So, this was the code that you turned in for this morning's deadline. And talked to a lot of people about this throughout the day yesterday, and I think a lot of people figured it out in the end. So you're writing a function that takes a character array, removes all the x's, and returns. Now the function is void, so it doesn't actually return a value, right? But the character array itself gets modified. So your main program calls clean. When it comes back from clean, the argument it passed to it should have the x's removed. And so we played with this in some sample code at the end of class yesterday when we wrote a clean function that would truncate its argument, which was a string. And we saw that changing the string in the function changes it in the program that calls the function. So here the goal was not to truncate, but to remove all the x's. So a lot of ways to do this. So let me show you one solution. So incoming argument I called in. Old is going to be my copy of it. So start off by copying in to old. So old is now, a copy of my original string. J is my output location. Terrible variable name, but we'll see a different version of this in a bit. And then basically loop through the original string up to and including the null terminator. Now the less than or equal to, that equal sign says including the null terminator. So for each character in my old string, if it's not the letter X, I copy it into my new string at position J, and then I increment J. That's my output location. And at the end of this loop, I'll have finally reached the null terminator, right? And that's not equal to X, and so that null terminator would have been copied into the next position in the output string. And then you exit the for loop, and your function returns because there's no more code in it. And this argument in has been, replaced with a cleaned up version of the original argument. When you said return, it tripped me up a little. So every function has to return, right? And you can be explicit, and I probably should be. Just go ahead and return right there. But if you run out of statements, right, your function returns. Same as with a main program. If you just hit the last line of your main program, then it'll go ahead and return. So let's see. Didn't you say not to use things like J++ in the command because it can mess us up? So I think I said that for the Bash program, because Bash can be a little funny about it. And I was concerned if you did something like I equals $, I++. Right? That can be a little strange. We're actually going to look at an example of that. But for C, it's perfectly fine. Although we'll see an example of where this can get you into trouble, perhaps in C, in a little bit. All right, and yeah, you can't return a string, for example, because the function is void, right? And returning a string would be a whole different matter. It gets into something else that we're not ready to talk about yet, but that would be, you know, local versus static variables and memory reallocation and so on. For strings, the easiest thing, if you can, is just to change it in the argument itself. All right, so ODP 452, almost exactly the same deal, with one minor change, which is you only want to remove the first occurrence of the letter X. Okay, so it looks exactly like 450, but it only removes the first time that you find a letter X, and all the other X's should stay the same. So it's a simple difference, but it can be a little tricky to actually code. So let's say this is our input string, and we want to create our output string. Well, we did this yesterday, right? We'll take the letter H and we'll keep it, we'll take the letter E and we'll keep it, we'll take the letter X, and we'll drop that, right? And we'll take the letter A and keep that, put it in the third spot. But this time, when we get the letter X, we've already dropped one X, so we're going to keep that. And we'll keep the O, and we'll keep the N, and we'll add a null terminator. And so that's what we want our output string to be. All right. Well, what happened in there? If you caught it, I did something a little differently. The first time that I encountered this X, I said, nope, I'm not going to keep it. The next time I encountered an X, I said, I've already skipped over an X once, I'm going to keep this one. All right. So what's at work here is the notion of state, as in Engineering 250. Someone asked, could you have used an if and else in 450? Yeah, you can use that, as long as you have a loop around it. There's lots of different ways you can write the logic for copying or not copying. All right, let's look at some pseudocode for this. And it'll be very much like the code that we saw yesterday. So for each character in the input, if the character is not equal to an X, let's copy that character to our output location. All right. And let's initialize our output location to 0 and, you know, some sort of output array that we can write into. So for each character in the input, we're going to do the following. If the character is not an X, we're going to copy that character to the output location. All right. And then, you know, add the null terminator, copy to your input, etc. Okay, so how do we change this so that we only ignore the first X? We're going to need a flag. All right, Because what we did when we went through this by hand was in our head, in our memory, we made a note of the fact that we had skipped an X. And the next time we found an X, we looked at that flag and said, oh yeah, I've already seen an X, and so we decided to copy it instead of skip it. Okay, so let's make a flag. We'll make a flag called I have skipped an X, and we'll set it equal to 0. Okay, so see, 0 is false, non-zero is true. So the usual values we use are 0 for false and either 1 or -1 for true. But anything non-zero is considered true. So you can actually use an integer variable as a Boolean expression. You can say if I have skipped an X, and if this is 0, it'll be false. If it's non-zero, it'll be true. So I'm just using this as a flag. So if character is not equal to X, or I have skipped an X, in either of those cases, I'm going to copy my character to my output string. And then the only other thing I need to do is make note of the fact that I've skipped an X. So if character equals X, then I have skipped an X equals 1. I'll set that flag. And if you wanted to be totally precise about this, right, probably what I should say is if character is equal to X and I have skipped an X is equal to 0, then set this equal to 1. But I don't mind setting this to 1 multiple times, right? Anytime I find an X, I know that I might have skipped it, I might have decided to include it anyway, but anytime I find an X, I'm just going to set this flag to a 1. That's going to work great. All right, so here's my input. Here's my output. Here's my output location, which is initialized to 0. Here's my flag. I have skipped an X. That's initially 0. Alright, so output location is 0, skipped an X is 0. I'm going to go through each character in my input. Okay, so first I'm going to look at this character, that's the letter A. If the character is not an X, well, it's not. So right there we know we're going to go ahead and do this statement. So I'm going to set output bracket 0 to be equal to my character. That's going to put an A right there. And after I do that, I'm going to increment my output location to 1. Okay, if you don't like this, just put an extra statement after here saying outlook equals outlook plus 1. Same thing. Alright, now I'm going to go to the next character, which is an X. I'm going to say if character is not equal to X, well that fails because the character is X. Or I have skipped an X. Well, I have skipped an X is equal to 0. That fails also. So, or I have skipped an X equals 0. Let's do that. Okay, so there's the letter X. If character is not equal to X, that's going to fail because the character is X. Or I have skipped an X equals 0. Well, that's true. Okay, I have skipped an X is equal to 0, so I'm going to go ahead and copy my character into output location outlook. So my character is X, outlook is 1. I'm going to put that X right there. I'm going to increment outlook to 2. I'm going to go back and look at my next character. Oh, I'm backwards here. I did this last class too. Let's back up. Output location was 1. Let's look at the X. Okay, if character is not equal to X, that fails. I have skipped an X. That also fails because it's 0, so it's going to skip this body of the if statement. So it's not going to copy the X, and it's not going to change outlook. But character is equal to X. That's going to change our flag. I've skipped an X is going to become 1. Alright, now we're going to go on to the next character in our input. That's the letter B. That's not equal to an X. It's going to copy that to output bracket outlook, which is 1. That's going to put a B right here. And then we're going to increment outlook. Then we're going to go to the next character of our input. That's right here. If character is not X, well, that's going to fail. But it's an OR statement. Or I have skipped an X. Well, that's equal to 1. That's true. So the if condition is true, so it's going to go ahead and copy the character to output location 2. So it puts that right there. And then it increments output location to 3. And then finally, last character, it will pick up the C. It's not an X, it'll copy it to output location 3, which is C. And that will be the end of our for loop. And we can add the null terminator, or if we went up through and including string length so that we also picked up the null terminator, right, we could also take that and copy it to our output location. So the only difference between this and 450 is the notion of this flag. But what we're really doing is we're building a state machine. Right? So what is a state machine? It's a machine whose behavior depends on things that have happened in the past. Okay, so think back to 450. Forget about flip-flops and state transition tables and all that, but think about the general notion of a state machine. Combinational logic, all you needed to know was the inputs, and that would tell you the outputs. A state machine, just knowing the inputs isn't enough to tell you what the program is going to do. Okay? I see a letter X. Am I going to copy it or am I going to skip it? I don't know. It depends what's happened in the past. The code doesn't just say if it's an X, skip it. If it's not an X, copy it. It has to know, have I already skipped an X? So you're actually building a little state machine with two states. State 0 and state 1. State 0 says copy if your character is not the letter X. State 1 says copy all characters. If you're in state 0 and your character is not the letter X, you stay in state 0. If you're in state 0 and your character is the letter X, you go to state 1. So we start off in state 0, that's our initial state. And you copy characters, you keep going back to state 0, you're just hanging out here forever until you get to an X. If you get a letter X, you're not going to copy it to your output string. And then that character X is going to change you to state 1. And in state 1, you copy all of your characters. So after that, if you hit an X again, it gets copied just like any other letter. All right. So stateful programming is a key thing. And almost all the programs that we deal with are stateful. Right? Any time that the behavior of something depends on what's happened in the past, you've got a notion of state somewhere. And that's almost everything, right? Everything that we do in our computer, if I hit the enter key, is my computer always going to do the same thing? Absolutely not. If I'm in a text processor, it's going to move down to a new line. If I'm in VI, it's going to do who knows what, right? If I'm sitting on top of a highlighted button in a GUI, it's going to click that button. If I'm sitting in the middle of my window and there's in the middle of my desktop and there's no windows open, the enter key is probably not going to do anything. If I've set up a shortcut for the enter key, it'll do something else. right? So the behavior of this program depends on what's happened in the past. In particular, have we seen an X yet? All right, so that's 452. Play around with it and think about this notion of adding state. All right, questions on that? So let's talk about debugging, and in particular GDB. GDB is probably the most powerful tool, other than the C compiler, that you're going to work with in at least this part of Linux. GDB is huge. It's the way to debug code if you don't feel like adding a million print statements to your program. And I want to go through some examples of using GDB to do some debugging. And I want to start with this. Here's a version of ODP 450, okay, which has better variable names. My input's called new, my output's, but my temporary is called old. I've got a character. I copy my new to my old. Here's my output location. I go through all the characters in my original string, save the character in C. If it's not an X, I copy it to my output string and increment the output location. And then at the end, I store my null terminator. The only thing missing from this is comments, right? But you know, this is a clean version of ODP 450. If you wrote this, you don't want to just go ahead and assess it, okay? You want to test it. Anytime you write code, you want to test it to know if it works correctly, okay? Compiling is one piece of that. If your code doesn't compile, it definitely doesn't work. But if it compiles without errors, without warnings, right, you still don't know if it actually works. So you have to write test code. So here's some test code that we looked at a little bit yesterday to work with the clean function. So there's a lot of different ways that you could test your function. But this one basically lets me type something in while the program's running. I decided to get rid of the null terminator because I wanted to see if my code worked with empty strings. And if I don't do this, I can't actually input an empty string. If I just hit enter, it'll still have one character. So I decided to get rid of the null terminator, the new line, and then I print out the string before, I call clean, and I print out the string after. So I can run this, I can say hello, that works fine. I can say hexop, and that works fine. That seems to get rid of my x's. I can put in something with a bunch of x's, 1x, 2x. I can put in an empty string. I can put in an x in the beginning. I can put in an x at the end. I can do combinations of that, right? And this is really easy to try lots of different test cases, right? And you know, these ODPs, sometimes they run 10 different tests on your function, and a lot of those are about testing edge cases. An empty string, a string that's going to be turned into an empty string, a string that should remove the first character or the last character, those are special cases. And slight imperfections in an algorithm will often be exposed by looking at edge cases. So you always want to write yourself your own test bed, okay? Which for me was just, you know, this main program that we used the other day, but it could take a lot of forms. The advantage of this is that if your code has a problem, right, you can use various debugging techniques to figure out what that problem is. Whereas if you just go ahead and assess it and you get 0 out of 10, all you can do is stare at your code and hope you see a problem, right? So how do we actually go ahead and find the problems in our code? So here's a different version of my clean function where I'm using a ++ instead of a separate statement saying outlook equals outlook +1. And let's go ahead and compile that. And let's run it. and let's say hello, and this doesn't work right, right? Somehow it doubled my first letter and it lost my last character. And you know, if I have a string with x's, that doesn't seem to work right either. Well, if I try AX, that seemed to work fine, right? But lots of test cases, right? Letter X, hey, that removes it correctly. That works great too. Am I ready to assess? No, try more cases. Right? That might look good, but if you look at it closely, that's not actually what it should have been. It should have been HAAA instead of HHAA. So there's something wrong in my clean function here. Okay? So we're going to play around with the debugger. So the GNU debugger is GDB. And when you want to debug a program, you say GDB and the name of the program. And you can use GDB on any program that you can execute. It doesn't even have to be a program that you wrote. I can GDB /bin/ls, right? And I can start debugging, you know, the ls command. The thing is, if I debug my program, chances are I might get this message down here at the bottom. No debugging symbols found. Okay? If you're debugging a program that you have the source code for, you can do more with GDB. Okay? So right now, you know, I've just got you know, a debugger that's not going to get me very far. So here's what you can do. When you compile your program, put a -G switch in the beginning. Okay? The -G switch says include debugging information. And it will compile in things that will help you use GDB with your code. Now, if it's not your program, if you don't have the source code, then you can't compile with a -G switch. You can still debug, but it's a totally different experience. But here I'm going to say GCC-G, and now when I say GDB main, it tells me reading symbols from main, done. Alright, well now I've got a really rich environment that I can use to try to figure out what's going on with my program. So what can we do? We can say list, and we can look at our source code. So list will show you a listing of your source code. If I say list again, it will show me the next 10 lines of my program. Well, my program only has 14 lines, so it only showed me 4 more. And if I say list again, it'll show me there is no line 15. But if I say list 5, it will show me some statements around line 5. Alright, you can also just hit the enter key to repeat a previous command. So if I say list 1, right, and I hit the enter again, it'll repeat my list command and it'll show me the next section of code. Okay, so one of the main things we do with the debugger is we set breakpoints. We can say when you get to a particular line of code, I want you to stop executing. And I want you to come back and give me control so I can play around and look at things. So we can say break. We can say execute the next line of code. We can say execute the next line of code as we step into a function call. So if you've got a function you're calling and you want to go to the next line of that function, we can use step. Usually we'll just use next. We can say print, or just p, to look at the values of variables. We can say x to examine the contents of memory. We can say set to change the values of variables. We can say watch and give the name of a variable. And this is useful, for example, if in your code you've got a variable, let's say it's a flag, which should be a 0, but for some reason it's getting set to you know, -35, and there's nothing in your code that says set this to -35, right? You can put a watch on that variable, and you can run your code, and the debugger will execute your program, but it will keep an eye on that variable. And as soon as that variable changes value, it'll stop executing, it'll come back to you, and it'll say, hey, this variable had a value of 0, now it's got a value of -35. We're at line, you know, 118 of this file, what do you want to do? Okay, so this lets you run your code in a really controlled way. So I'm going to do the following. I'm going to put a break at my clean function, and I'm going to say run. That's how we start our program executing. And remember, my program wants me to type in a line of code. So I'll type in hexaxon. Actually, we can make it misbehave pretty easily. I'll just type in hello. Okay. And my program continued to run, and it got to my function clean, which was a breakpoint, so now it's stopped. And it's waiting for me to tell it what to do. Okay, so it's telling me that I'm in a function called clean. Clean was called with a string containing the characters hello. Because I compiled with a -g switch, GDB knows that clean expects a char star argument, and so it looks at this location in memory. It finds characters up to a null terminator, and it prints those out for me inside quotation marks, right? So it will work with you to help you understand what's going on in your program. Okay, the G switch is really key. All right, so I'm inside my function. I called it correctly, so my test bed's working great. Let's do a list. What's about to happen here? Well, I'm going to string copy new to old. I'm going to set an output location. I'm going to go into a for loop. If my character is not an X, I'll copy it to my output. I'll bump up my location, and I'll do that until I get to the end, and then I'll add a null terminator. Okay, let's say next. It's about to execute statement 6, string copy new into old. This was where we were making a copy of our input argument. So let's just look around here. Let's see what's going on here. Print new. New is the string hello. Print old. Old is gibberish. Okay, it's a \26, a space, a back quote, and a null terminator. Why is that what it is? Because I haven't put any characters in particular into this array. I declared it. I set aside memory. I had old point to the first location in memory that we've allocated, but I never stored any characters in there. But we can still play around with things in here. For example, I can say print old bracket 0, and I can see the first character of old is that octal 26. I can print old bracket 1. That's got a value of 32, which is the character space. I can print old bracket 2. That's the value 96, which is the back quote character. And if I print old bracket 3, that's a value of 0, which is the null terminator, or hex 0. I can print the string length of old. String length is a slightly odd function. It doesn't actually return an integer. So it'll tell me I have to cast the integer, cast the return value. So I'm going to print string length converted to an integer, and it'll show me my old string has a length of 3. If I print string length of new, that's equal to 5. Remember, new is HELLO. We spent some time earlier saying that if we wanted to get to the last character of a string, it would be the character at string length minus 1. So if I print new bracket 4, that's the O. And we said the null terminator should follow that last character, which means the null terminator is at the index given by string length. Well, string length gave a 5, so my string bracket 5 should be the null terminator. So let's take a look at new bracket 5. There's the null terminator. If I set new bracket 4 to be a null terminator, and I print out new, it's a 4-character word now. It is a 4-letter word. Right? So you can look at variables You can look at elements of arrays. You can make some changes to variables in arrays, right? You can do a lot of examining and manipulating the environment, and that can help with, you know, trying to understand how some of these things are set up. So this is an environment not just for debugging when you have a problem in your program. It can also be an environment for exploring. All right, so we're about to do the string copy function. Let's go ahead and do that. So I'll say next, or just n for next. And I should have done that string copy from new into old. So now if I print old, that's also HELL followed by a null terminator. All right, so the string copy worked. And we're about to set our output location to 0. Well, let's look at our current value of output location. It's not 0. It's 2,656. Why? Who knows? But I did not initialize output location when I declared it, so it has an effectively random value. But I'm about to, well, I didn't declare it at all, but until I do this assignment statement, we can't rely on the value of this variable. Okay, so line 7 is going to set output location to 0, so let's go ahead and execute that. And now if I look at output loc, it is 0. Alright, so our input string, our output location, those are all set and ready to go. Let's go into our for loop. So we'll go in here and we'll print the value of I is 0. We're going to look at the first character in our input string, so let's look at old bracket I, and that's the letter H. That should be, you know, that's what we were expecting. That is not equal to X, so it should go into the body of our if statement. And that says copy old bracket I to new loc bracket plus plus out loc. Alright, let's take a look at new before we do this copy. Let's execute this statement. Let's take a look at new after that copy. And right now we've got our problem, right? This is where our algorithm went off the rails. So something in this statement did not do what we were expecting it to do. All right, so let's go back around the loop again. We'll look at old bracket I, that's the letter E. We'll look at new, it's HHLL. We should be copying an E to index 1. So let's execute that statement and take a look at new, and it looks like it copied it to index 2. Okay? Something is wrong here. And this is the point of epiphany. Okay? This is not the point where you want to delete your code and start over. You're on the cusp of some great breakthrough right here. When you get to a point where you're convinced that one thing should be happening, but you see clear evidence in front of you that something different is happening, that's a moment of triumph, right? That's where you're going to figure something out fundamentally vital, right? So what's going on here? Outlook was equal to 1, but when I did this statement, it copied my character to position 2 instead of 1. And so this, you know, is where you go off, you take a walk, you put on some music, you clear your head, and then you come back and you look at this with fresh eyes, and eventually, right, what you'll realize one way or another somehow, right, is that this is what's called a pre-increment. This statement here says, first I want you to increment output location, then I want you to use it. So even though output location is 1, when this statement gets executed, the first thing that happens is output location changes to 2. And then it copies my old character into location 2. And once you remember that, right, now the behavior of this code makes absolutely perfect sense. And so what do? You go back in here and you change this to outlook plus plus, or, you know, if this is just not making any sense to you, you just change this to do outlook equals outlook plus 1, and you run your code and suddenly it starts working. All right. So the debugger is about figuring out where something is going on that's different from what you think should be going on. Now, it doesn't help you after that to say, you know, oh, you forgot about pre-increment versus post-increment, or something like that, right? But it will let you concentrate your focus on usually one particular line of code and say, you know, I thought this would do this, but it's doing that. And then that's where you go off and you try to figure that out. And bugs are your friend, right? If you forget a semicolon and you put that in, right, that can be a pain to find. That doesn't really, you know, teach you a whole lot, except don't forget to put your semicolons in, right? The first time that you do something like this, it might take a really long time to figure out what the problem is. But once you've gone through this process and you've done this, I guarantee you understand the difference between pre-increment and post-increment, right? So these are learning opportunities, and the bigger the bug, the greater the reward once you figure it out. Don't ever just get rid of a bug, though, right? If your code's doing something weird and you cannot explain what it's doing, that's a huge learning opportunity. Keep that code, make a copy, save it somewhere. And if you need to get your assignment turned in, yeah, go ahead and just start changing things and get it to run. I understand that. But at some point, go back to that code with the bug and figure out what that bug is coming from. Because I guarantee there's something vital to learn in there. And GDB is a tool that can help you with those explorations. So here's a different version of clean 2 where I moved the output location statement into a separate section of the code. So let's go ahead and compile that up. And I'll say hello, and my string is empty. And I'll say HAX, and my string is empty. And what's going on there? Well, I don't know. Let's run GDB. Let's put a breakpoint at clean. Let's run. Let's say hello. And let's start stepping through here. So I'm going to copy my old bracket I, which is the letter H, to location 0 in my output string. And there's no plus plus here, right? So this should definitely copy the letter H into my output string. And if I look at my output string, sorry, my new string, right? It's still got an H in position 0, so that's good. Okay, now I'm going to set output to outlook +1. I'm going to go back around my for loop. I'm going to look at old bracket I, that's the letter E, that's good. That should get copied to my output string. I'll take a look at outlook. Outlook is still a 0. And so when I make this assignment and I print new, my H has disappeared and I copy that E into position 0. Well, what the heck? So what's the value of outlook? It's 0. I'm about to say outlook equals outlook plus plus, and when I print outlook after that, it's still a 0. Ding, ding, ding. Fundamental misunderstanding. This does not increment outlook. So this was the version of plus plus that I mentioned in Bash can get you into trouble. This does not set outlook equal to outlook plus 1. This sets outlook equal to outlook plus 1, but after that it assigns outlook to the previous value of outlook, which was just outlook. It's a no-op. It doesn't do anything. You probably wouldn't find that by staring at your code, but the debugger forces you to the realization that this is not incrementing my variable. It won't tell you why, but it will tell you exactly what the problem is and where it's occurring. And then you go off and you try some different things. You replace this with outlook equals outlook plus 1. Your code starts to work, and you put that on a post-it note and you come back to it later. All right, so those are some GDB examples. We'll play around with this a little more tomorrow. We'll look at some other examples of this. And I'd encourage you just to start using GDB when you're trying to find bugs and you're trying to figure out what your code is doing, right? Start using GDB. So we'll play with this some more tomorrow. We'll look at some examples and stuff. All right, have a good one. I will talk to you tomorrow. Thanks.